Hello, nice to meet you. My name is Pablo Garcia and I work for the company WEHRLE. WEHRLE is a German company specialized in high polluted wastewater and leachate treatment with over 30 years of experience. We'll now proceed to present some basic concepts about leachate management, starting with a brief overview about landfill emissions and its need of management, and for this purpose the most proven treatment technologies, finalizing with some information about case study from the leachate management in landfill Munich in Germany, and some interesting figures about life cycle costs within 2 decades of operation of this plant. Talking about global waste treatment and disposal, landfilling is still number one for waste handling. However, this chart shows that still 1/3 of the global waste is still going to dump sites, and therefore is still a lot of work to be done in order to try to reduce this. And for this purpose, ISWA is taking action with this challenge of trying of closing waste dump sites globally. Main emissions of a landfill are biogas, which generates CO2 and methane, both main causes of the greenhouse effect, and leachate. That's a very polluted effluent coming from waste moisture and rainfall that in case of uncontrolled discharge may cause environmental pollution. Whilst the landfill biogas can be processed and converted into heat and electrical power in a cogeneration plant with a positive impact on operational costs, landfill leachate instead must be properly treated before it gets into the nature. Leachate treatment usually means no benefit to the operator and only costs money even many years after the landfill has been closed and stopped receiving incomes. For this reason, it is required a long-term leachate management system that considers not only cost-effective investment and operational costs, but also a real sustainability throughout the whole life cycle of the landfill. Apart from having a sustainable cost, leachate management has mainly two objectives. On the one hand, it's important that the landfill body doesn't get unstable because waste layers disposed could start to slide, which may cause and has unfortunately already caused fatalities, and on the other hand, to prevent pollution of the environment. Here are some press clippings of real disasters caused by mismanagement of landfill leachate, including those of an accident that took place in February this year at the Spanish landfill site Zaldívar in the Basque Country, where the lack of leachate treatment produced a landfill collapse causing the death of 2 landfill workers. Having a suitable leachate treatment can also have positive economic effects for the landfill, and a good example of that is the case of the Jebel Sekia landfill site in Tunisia. The picture on the left, you can see how it looked the Tunisian landfill site just after having installed the leachate treatment plant, how much landfill space was occupied by leachate storage lagoons at that time. On the right picture, you can see the same site 4 years later after having commissioned the leachate treatment plant, and the plenty of space is now available for waste disposal, increasing the capacity and providing a longer life to the landfill. When we design a leachate treatment concept, we must consider the discharge requirements. In case of indirect discharge, where treated leachate still goes through a wastewater treatment plant before being discharged in the environment, could not require such demanding and expensive treatment as could be in the case of direct discharge, for example, required in many landfills that don't have a treatment plant nearby. One of the most proven leachate treatment technologies is reverse osmosis. With a reverse osmosis, an effective separation of pollutants and an excellent effluent quality is achieved, but no actual pollutants elimination takes place, but all of them are concentrated in a so-called concentrate stream that requires an additional management or external disposal. Reverse osmosis technology is characterized by a simple setup and operation, but as said, the big drawback of this technology is due to the concentrate generation, since if concentrate is returned to the landfill, a reconcentration of the leachate will take place and treatment capacity of the osmosis will decline over time, even making the treatment unsustainable in the medium-long term. The other most proven leachate treatment technology is Mbr Process. Mbr means membrane bioreactor and consists of a biological stage where elimination of the organic and nitrogen pollutants is achieved and the sludge separation is carried out through external ultrafiltration membranes. The effluent quality coming out from an Mbr process is typically sufficient for an indirect discharge. It is a fully automated process with low and predictable operating costs and which is capable of being combined with other tertiary treatments such as nanofiltration, reverse osmosis, or activated carbon in order to achieve the highest discharge requirements or even for irrigation purposes. One of these Mbr processes was installed by one of the largest public waste organizations in Germany, responsible for waste disposal of the city Munich in Bavaria. This plant was installed in 2000 on a landfill which received municipal solid waste since the 70s. WEHRLE was asked not only to supply the installation, but the City Council of Munich also handed over the operational responsibility in a full-service contract to WEHRLE, which enables us now to report about 2 decades of reliable and successful leachate treatment in a life cycle review. Munich leachate treatment plant can treat more than 120 cubic meters a day, roughly 32,000 gallons a day of leachate, and figures above for COD and ammonia in raw leachate are typical values for German landfills and might vary from other local figures all over the globe. Over the years, leachate treatment process has always been optimized in order to minimize its operating costs but always keeping excellent availabilities and results over its life cycle. As in Germany, the landfill are closed for domestic waste, the biodegradability of the leachate, expressed in the BUD-COD ratio of round about 10%, is very low, increasing the difficulty of treatment. This kind of leachate is typical for all landfills short before or already in aftercare period. Let's have a look into detail. The Munich leachate treatment plant consists of a membrane bioreactor with external tubular ultrafiltration followed by the polishing step with granular activated carbon. Activated carbon was added to the process due to the very low ratio of BUD-COD and the requirement to fulfill local limitation for halogenated organic compounds AOX for discharge. All in all, ammonia is fully eliminated and COD and total nitrogen by 89 and 87% respectively, coming out with a COD about 400 mg per liter and a total nitrogen about 240 mg per liter. Treated leachate is indirectly discharged to the nearby sewage treatment plant for final processing. Here you see annual treated leachate quantities more or less very close to the design of 45,000 cubic meters a year, roughly 12 million gallons a year, and overall quite constant. It's important to highlight that since 2005 it's not allowed in Germany anymore to dispose organic waste on landfills, and since then the landfill has received only construction demolition material waste, and the landfill operator has used temporary capping upstream to avoid additional leachate creation. This graph shows that the landfill operator was very successful in keeping leachate quantities under control over decades. But what about emission of contaminants such as ammonia organics? With this graph, it can be clearly seen that the landfill is already quite old, evidenced by overall decreasing figures of the average concentrations for both of the main contaminants in leachate, ammonia and COD. In 2002, the client started to cover some parts of the landfill temporarily. Since 2005, only inert material was disposed on the landfill. By decision of the client, the landfill was not finally capped. Out of this reason, decreasing figures above are caused by ongoing percolation of the landfill for decades. Ammonia and COD were more or less washed out and could be converted to atmospheric nitrogen and CO2 by the leachate treatment plant. What kind of activities for optimization can be carried out on the leachate treatment plant, and what does it mean to the operational cost of the system? This graph shows the reduction of the operational cost for treatment of leachate in the last 2 decades, including all consumables like energy, chemicals, activated carbon, and maintenance including membrane replacement, that have been able to achieve through several modifications carried out in the treatment plant within the evolution of technology and taking advantage of its modularity. Improvements carried out have been the following: In 2003, an upgrade in the irrigation system and the blower capacity, which led to a significant reduction in energy costs. In 2010, an installation of a new advanced low-energy ultrafiltration system in combination with the modernization of the control system was carried out. And in 2016, activated carbon systems were taken out of operation and no longer necessary, as the requirements for discharge are already fulfilled after Mbr. Overall, the treatment cost for leachate could be reduced by nearly 50% over 2 decades, keeping all capabilities of the original installation for peak loadings. Quite sure you might be interested in knowing overall costs and how much money was spent on leachate treatment in Munich in the last 2 decades. Here you can see the average specific cost to the city Munich due to leachate treatment throughout 20 years of operation, considering total costs, which takes into account not only all fixed investment costs carried out, but also variable costs all over these years, such as consumables, maintenance, quality control, insurances, reports, and loads for the operator at European prices. To finish, let us make a summary of the achievements made in Munich plant through these last 20 years. First of all, a real elimination of liquid emissions from landfill took place for over 2 decades. There was no risk of leachate reconcentration that could have been taken place by circulating concentrates from separating processes like reverse osmosis, for example. The installed technology could be upgraded or extended several times, showing flexibility and modularity. But unfortunately, leachate treatment costs cannot be completely avoided, but kept indeed at a minimum at all time, keeping the safety for the environment. Based on the experience of these 20 years of operation in Munich leachate treatment plant, we have enough evidence to be able to say that it's indeed possible to create not only technical but also economic sustainable solutions for leachate treatment. Thank you very much for your attention, and don't hesitate to contact us whenever needed.